welcome. We're glad you could make it. We've been really excited and have got a lot of great feedback about this Mastering OTel series, these series of workshops. So kicking off today, we have Mike, who is the CEO of ObserveIQ, and he's going to walk us through the OTel distro and building this with a step-by-step guide. There may be a lot of questions today, so feel free to put them in chat. And when we're done with the presentation, we'll open it up to questions and let everybody ask those questions, and Mike will address those. And then Mike also has this slide up right now. We have a handful more in this series, so we'll send an invite out soon for those. Feel free to share that with your colleagues. We're excited for those future workshops. Mike, take it away.
Thanks, Darren, and thanks everyone for joining. These have been fun, and I particularly was looking forward to this one, getting into a little bit about what it takes to build a custom OTel collector, things to consider when you're doing it. I think it's a decision that a lot of companies are trying to make, and then they want to understand it at a deeper level. So we'll walk through that today, and like Darren said, feel free to ask any questions as we're going through it. I'll try to answer what I can. So a few things, we'll do a little bit of just an overview, talk about some things to consider, recommendations, the collector builder, and how to actually do it. And I'll actually walk through building one yourself, which once you understand how to do it, can be pretty easy. And then talk about the CI/CD process and doing it the easy way versus the hard way, which isn't always possible, but if you can do it, and there's a good template that we can use. So for everyone on here, I think we know what OpenTelemetry is. We're specifically talking about the OpenTelemetry Collector today. And just, as a refresher, it's mostly made up of a set of components and modules, a set of receivers, processors, exporters, also connectors, extensions, and it's built to be very extensible, right? So that's one of the benefits and also complexities of the collector. It's designed to pull these pieces together in whatever form you want. And so when we look at like the contrib collector, that has a lot of the components baked into it. So it's easy to use out of the box. You're unlikely to run into something that you need that doesn't exist. But there are times when you say, well, I actually don't want these receivers. I don't need these processors. Really want to reduce the footprint as much as possible. And maybe I'm building some custom components that, I'm not planning to push those upstream. In those cases, it can make sense to consider building your own collector. So just, we talked about the distros before. There are official distros, vendor distros, or you can build your own. And so today we're going to talk about building your own. But we're going to start from contrib, and I think this is usually the best way to do it. It's not required, but we'll talk through why you want to start with that and then take things away, as opposed to starting from nothing and building your own. Couple of things that I recommend considering. One, but before you go down the path of doing this, and it's a great experience just to do it, to try it and understand the collector better. Before you go to production, a lot of users, there's an existing distribution that's a great choice, but we know in some scenarios you need something custom. So what I consider before deciding to build your own distro and use that in production is, when would you want to do that? One is you do require either custom components. So maybe you need to build a receiver for something that is only going to exist in your environment. There isn't a receiver or say exporter that exists. There's no standard format that you're able to rely on, and you're not going to be contributing it back. If it's something that you think you'll build, but it's going to be useful to the community and maybe it makes sense to open source it, then you might go down the path of just building it and submitting it to the community, and then it becomes a core part of OpenTelemetry and is supported by really everyone in the community. Sometimes you have, I think OTel gets patched quickly, but sometimes you need something immediately, and you need the ability to, build it yourself, put something in, and make changes. And you think on your team, if you're willing to put the resources to having a team maintaining a collector or some folks that are maintaining that and are also able to make those changes quickly, you can do that with a custom distro. Sometimes there's and sometimes this concern is, I think, maybe considered when it shouldn't be, but if there are significant resource constraints and you really require the smallest possible footprint. So sometimes this is in the case of IoT type of devices. And it's more on disk, but also can be some memory footprint. And you want that to be just the tiniest footprint and binaries that you can get. You might want to consider a custom distribution, strip out everything that you don't need and just those minimal components. And then there are other, this is mentioned in OTel, the security-driven effort, right? So if having different components does increase an attack surface to an extent, you always have to balance that with the idea of do you have the resources on your own distro where it outweighs the benefits of using the existing distributions and getting the updates and being able to pull in the changes really quickly. But those are good, I think, reasons to consider having your own custom distribution. And it's something that OpenTelemetry is designed to allow for. So if one of those makes sense, then I would say there are a few things that we recommend, that the community recommends, and we'll talk through each of these. But one is there's a component within OpenTelemetry called the OpenTelemetry Collector Builder, and it's just a utility that makes it easier and standardizes the way that we build collectors. So we want to use that whenever possible. I recommend starting with the OTel contrib distribution, removing that, adding components. The reason for that is the closer you can stay to existing distributions that are frequently updated, that have the community behind them, closer you are to those, the easier it's going to be to maintain a distribution going forward, to pull in changes and always have the latest. The further you deviate from that, the more likely you're going to run into issues or incompatibilities, or maybe get further behind, or there might be something in the build process or the components that doesn't work the way that you expect it to. So I think the closest, and you'll see that with a lot of these are really just staying as close to the standard process as possible, and then pulling away the way that OpenTelemetry is intended to be decomposed or composed, depending on what you need. We'll also talk a little bit about the existing build processes. So it goes beyond OCB and into how do you automate, what does CI/CD look like, what are the existing solutions for that are in place right now, and then how do you fit that into your own tooling. And I'd recommend that it can be you can build the collector quickly, but before you go into production, you want to make sure you have a CI/CD process, you have a release process in place, just so you have that, and it makes it easy to make changes, make updates, and it's not a manual process before you go into production. So the first thing I'll talk about is the OpenTelemetry Collector Builder. And this is, I'll talk a lot about it. It's a pretty simple utility, but it's a tool that was designed within the community because it wasn't very easy to build the collector. And so tool that was created to create those custom OpenTelemetry builds by giving it a list of all the components that you need and a little bit of detail about your collector and information, things like the name and some details we'll talk about. But this is an official tool. It's actually in the OpenTelemetry Collector contrib repo. It's maintained, and it's also used to build all of the official OpenTelemetry releases. So it's used to build core, it's used to build contrib, and the new Kubernetes release as well. It's just a single standalone binary, really easy. You just download it, and then it can run and generate builds. And then, when we come to why should you use it, it's really about, like I mentioned, simplifying and standardizing how you develop, how you make changes, and keeps your distribution as close as possible to the upstream distributions and standards. When it comes to how you actually use it, again, pretty simple once you understand it. You create a manifest. This is just a YAML file that includes details about everything that's going to go into your distribution, list of all the components, and then OCB does the rest. Mostly, I say. I mean, when I say mostly, it's all those other complicated parts about the release and building for different operating systems and architectures. That's handled separately, but the actual build with OCB is made simple. I have a few links that I'll send out after, with links to the collector builder and the manifest options. But I think we'll touch on most of those details here. Okay, so the first thing to understand is what goes into a collector. And we know it's receivers, processors, exporters, connectors, extensions. But in the manifest, it's defined in a specific way. And we'll look at an actual manifest file. And this is mostly directly from the contrib collector. But it's broken up into two main components. One is the distribution details. And all of these are details associated with a collector. So simple things like the name, description, version, where you want that build to go, the OpenTelemetry collector that you're basing this off of. All of these are actually optional, but highly recommend including most of them. They also all happen to map to command line options you can pass to OCB right when you run it from the command line. But this would be the normal way, the typical way that you'd run it. Build a manifest. This is your distribution. And then there's the component section. And this is where you're defining all the components that you're going to include in the distribution. So this is a sample of extensions, has a direct link to that extension that you're including. Same with exporters, processors, receivers. Then this concept of replaces, and this is an important concept. It's rarely used, but if there is an incompatibility between, say, receivers or processors where maybe a library or module is incompatible, you need to say, well, this one can't use the standard. We have to replace it with another module. Like I said, it's not frequently used, but we'll see this in a few places. So before I go into this part, let me show you the actual manifest from the contrib collector. Just so you see the maybe a larger version. And so this is the OTel collector contrib manifest. This is what's used to build the current, as of today, the collector contrib. And so it defines things like a best practice to define it as a module. It's OpenTelemetry Collector releases contrib. Has a name, has a description, the version of the collector itself, and then the version of the underlying OTel collector. So this is the version of the core collector. And then it says where that output is going to go. If you can, keeping these versions the same is ideal, but you can also version your collector completely separately. So if you have a distribution and you want it to be versioned out of line with the collector builds, it's totally fine. But if they stay in sync or they stay close, it's going to make it easier on you. And then the definitions here for each of those sections, like I said, this is just a list of every one of the extensions that are included, the version of that extension. Same thing with exporters. You can see there are a lot of those that are included in contrib. And then processors and receivers. And again, a lot of receivers that are included. And then a handful of connectors. And the replaces, so the replaces that are included in the contrib, every one of these, you can go into an issue, you can see why that was created. So if you are starting from this and removing, it makes it much easier you can go in and say, all right, do I still need these 4 replaces? Or you can just leave them and feel pretty safe leaving them as is. If you're removing from here, you know that's not going to be, you're not going to see anything unexpected if you remove or if you leave these replaces in place. Because the contrib collector is in use pretty heavily around the world by customers. And so you know this is going to be a pretty stable place to start from. One thing I'll note when you look at these is that, scroll to the top here. Within these, we have modules that are coming from the core collector, and they're going to look like this. Most of the time, you're going to want to leave these in here, unless you have a good reason to remove them. They're considered core functionality within the collector. If you don't need them, it's fine to remove them, but those are considered kind of key components. It'll still work if you don't include them, but I would normally recommend you leave those in. And then for all the others, it may not be clear just from looking at them. You know, a lot of them are pretty obvious. If you have a basic auth extension, you know, a health check extension, but some of them may not be as clear. So, you know, what is an ECS task observer? For any one of these, they are all going to map directly to the OpenTelemetry repo. And we pull up the right one. So if you go into OpenTelemetry Collector Contrib, you can look at the receivers. Let's say I have a receiver and I'm not sure what it's used for. Maybe it's this AWS Firehose receiver. You can drill in, you'll see exactly what it's used for, the specifics for configuration, and some details about it. And you can go into documentation if you want to get further, but it's a quick way to see if you're not sure, do I need this or not? Go in, you can double check going directly into the OpenTelemetry repo. So that's the quick overview of the manifest, and this is what we'll use and modify to build the collector in just a second. But what we need to do is download the OpenTelemetry Collector Builder. There are 2 ways to do this. You can just download it directly, and then you have a binary. You can put that binary anywhere, or you can run go install. And I recommend, and OpenTelemetry recommends, you just download the binary and you're all set. It's pretty simple. And that's available, I mentioned, in the OpenTelemetry Collector. This is actually the page with some details on it, but it's also available under the releases page as well. Then we'll take the OTel Collector Contrib manifest, update the details, remove any unused components. If we want to add any custom or external components, we can do that. And then we'll just build it and test it locally and verify that it solves your use cases. So pull up okay. So I have a folder here.
Mike, this is Darren. Sorry, we have a question. I'm not sure if you want to wait till the end or if you want to take that now.
Yeah, I missed it. Go ahead. I'll take it.
It looks like Joshua raised his hand, but I don't have the chat. So Josh, do you want to ask your question?
Yeah. Feel free to either, if you throw it in the chat, I'll take a look and try and answer it as we go.
Okay, cool. Yeah, looks like we'll wait for that.
Great. Okay, so I've just got a folder here with 3 files. I've got a manifest, got the OTel Collector Contrib manifest, and then a basic OpenTelemetry config. So this is just a configuration. It doesn't do much. In fact, it has a no-op on the exporter, but the manifest is what we're going to be looking at. So if I take a look at the manifest that we have, I started to remove, I started with the OpenTelemetry Collector contrib and removed some of those components that I didn't want to include in this collector, but that's the only change I've made. So I removed some of these. I can remove some additional. So I'm going to say I'm not going to use database storage in this collector. That's not necessary. I could also say I don't need in this case, I'm not running this one on Kubernetes, so I can remove some of the Kubernetes components. And maybe a custom sumo logic processor, a span processor I wouldn't be using. And we can go through and remove and pare it down to just what's needed. I'm going to leave all the replaces in here and not modify that at all. But what I've done is I've taken the OpenTelemetry Collector contrib manifest, reduced it to just the components that I need. But then I also need to change things like the module, the name, description, and I'm going to leave the version and output path alone. So in this case, I'm going to make this observe by Q. And we'll leave it as telemetry collector releases. We'll call this one custom. Again, this is optional, but recommended. What is important here is changing the name to identify it as Observe IQ Custom Collector. And we'll make this one a collector by Observe IQ. Okay, so now I've modified the manifest, and now I can go back here. And once OCB is installed, you can run it locally. I have it in my path. And it's actually version. Okay, so I can make sure that it's running. It's OCB version. I see it's version 0.98. OCB matches is released along with everything else with OpenTelemetry. So we can see we have the version here of the collector is 0.98. Version of OCB is 0.98. That's what you should be looking for, and that's ideal. You don't want to be using mismatched versions of the collector and OCB. And then once you do that, it's really simple. So we've done the hard work with the manifest. And now we can just run OCB past the manifest configuration, and it should have everything that we need to build. And really doesn't take long. It's going to download, compile, pull all the components together that we have just requested. And we'll see a new folder created called build. And it has the Go components in here. This is, if we look at one of these. You can see what it's actually generating. So it's pulling in all of those components that we defined, but it's putting it in a Go module. And those may not be necessary and maybe out of the scope of what we're talking about. The key component here is it did generate that collector. So now if I go into build, I have a valid OTel collector. And if I check the version, and I see, yep, I've got the version, or I've got that collector. And we can also use this command to see what are the components. So what did we include in that? Just a quick validation. And we should see all the components that we just listed. It gives a little bit of detail on those, about what the stability and levels are, what they're used for. And it's a quick check to just make sure, okay, yeah, did we build what we thought we built? Does it match what we expected? And then what's nice about this, we'll just note that the last one here is Z pages. So I can run this collector. I've got the basic config there. So if I just run collector config, and then I pass it the config YAML that I was using before. Now I have something running on this port, but other than that, I see it's starting up. It's working properly. I have another collector running somewhere, so it didn't like that, and it shut down. But I can a quick check to see, okay, is this working the way I expect? I can use can validate it against any use cases that I have. And this binary, you can take this and install it and make sure it solves the use cases that you've defined before going any further. And once you've done that, it's really easy to then go back and say, I really don't need Z pages. And so we're going to remove that. And maybe remove a couple of other items, but let's just stick with that for now. We made a change. Now we're going to build it again. And going to and run it again. We can list the components. And we'll see this time we removed Z pages. So you've got a really quick iteration cycle of removing items that maybe you don't need and validating it and building multiple versions. And that was the new collector. But like I mentioned, I also have this OTel contrib manifest. So I can just as easily say, I also want to build the contrib. And so this is going to take the manifest from the collector contrib. It's going to take a little bit longer because there's more modules there. And then if I look at it, it overwrote some files. So that's not best practice to do it this way. But we'll see now we've got the custom collector we just created. And then I also have the contrib collector. And you can see if you go in there and see, we removed some things, so probably a smaller package. And yeah, it's significantly smaller size on disk. Although when it's running, you're not going to see a lot of that unless you're using additional components in terms of memory and CPU usage. But if disk size is important, then that can be something that you're looking to reduce. Okay, so that was the quick run through. And we deployed, built two collectors now, OTel collector contrib, and then our custom collector. But one thing to note is, we ran it in this case on Mac OS. It only built one binary. It only built it for Mac OS. It's fairly easy to build it for all of distros, but that's not managed by OCP itself. So you can go through and change your cross-compile using Go. Everything here is in Go. Cross-compile for a variety of architectures and operating systems. But out of the box, when you just run it, it's only going to do it for one. So that was the quick, building a collector, seeing how you can iterate through and make changes easily. One thing I didn't mention is just like this is specifically calling out extensions, grabbing them from GitHub, can also include your own modules the same way. So you can build your own custom module and include it in here, and that's how you would add your custom extension or a custom exporter and include that in your build. So if you wanted, for example, to keep it as close to an existing distribution as possible, you could take this OpenTelemetry Collector contrib manifest, add your custom component, build it, and then you would have the exact same thing with one additional component that you've added. All right, so let me jump back and go from here. So we showed how you can build it, how you can validate, and this is a really good way to do some quick iteration and test it out. And so the next thing is, when we get to CI/CD. So we built a collector, but now we need to build it for multiple architectures, make sure that we're pulling in changes as needed, staying up to date with OpenTelemetry as well. So how do we do that? And that tends to be the hard work, right? So showed you the easy stuff. Now, how do you do all those other pieces? And I'm not going to walk through every step of that. I don't think we have time for that today, but I will show you exactly how you can do that in what we see as the easiest way possible. One thing, we see the challenges less as building the collector. We've made that really easy. Folks that design OCB on the collector, it's made that pretty simple. But keeping it up to date, managing builds for multiple targets. If you need packages for installation, say you want something for Docker or Kubernetes, that's going to be more difficult to do those builds and keep it up to date. And also the continuous patching, releasing, continuous integration. Those are all key things that tend to take more time. So I like to direct people to the OpenTelemetry release process. It's in line with everything I've said so far, and that the closer you can stay to the way the official distributions are built now, the better. This may not work in all of your environments, and you may need to modify this to fit into your build processes, but it's a great place to start. And if you can use it out of the box, it's a really fast way to start too. So we'll look at this in just a second, but in general, there is a dedicated repo for OpenTelemetry releases. It's part of the OpenTelemetry project. It handles multiple builds. Right now, it handles 3. It handles core, contrib, and a new Kubernetes build. But it can be extended easily to add more. Uses Go Releaser, uses GitHub Actions as the primary solutions for automating those builds. And it handles packages for Linux, Windows, Mac OS, a lot of common architectures that also can be expanded pretty easily as long as it's supported by an architecture that Go can compile to. You're likely to be able to support it. And it's a really good starting point. It gets you maybe 80% of the way there. It does require some modifications, and we'll talk a little bit about those. But let me go into the collector releases project. So this is, if you're downloading a collector release, you're probably downloading it from here. But the nice thing about this is that this has everything that they use to build those distributions. So you can see these are the 3 distributions that are included right now. But if you look at the actions, to this for a second, we have continuous integration running for contrib, for core, for Kubernetes. And we have release actions for contrib, for core, and for Kubernetes. And each of those, go in, you can see exactly what they do. This is a GitHub workflow. It's going to release this distribution. It's going to release it for these operating systems, for these architectures. And it's going to call this base release action. This is where more of the hard work is done. It's actually going through and using Go Releaser to build those, and then finalize and actually deploy them. And there's CI components as well. And each one of these is designed to work against these distribution folders. So if you look, you'll see some things that are very familiar. The core piece here is there's this manifest file. But then there are also other files like service files, pre-install, post-install. These are all necessary for your packages. So if you want to create Linux packages, you will need these files as well. And they're very straightforward. They can be modified very easily to fit your distro. In fact, almost every one of these is just a matter of changing the name of the collector distro to your name, and then it will just work. And then there's also the Go Releaser file. And this can be a little bit daunting. There's a lot in this if you're not familiar with Go Releaser, but there's very little that you need to change. And in fact, one thing that the project did is they wrote, there's a script here to generate the Go releaser file for you. And you can do that just running this. It'll generate a Go releaser file for you with the specific distro. And that's, that solves a lot of the challenges here. So if you are to simply clone this repository and do just what we did with the contrib manifest, started to remove the pieces that were not necessary, you'll be able to get maybe 80% of the way there with automated builds. A couple other things to look at. The makefile, familiar with makefiles, this is going to have all the individual tasks, things like the actual build. So in this case, it's using OCB to build. We can generate, there's a generate Go releaser task that's generating the new Go releaser files, pulling sources, and some additional validations in here. But relatively straightforward. So I'll pause here. I think that this is a really good strategy. Once you have the distribution and you have the components that you want defined, then putting them into a structure like this, where there are automated builds on pushes to main, the distribution is well defined. You have full releases for all the different architectures that you need. That's really going to get you to a point where you can feel confident about moving this to production. So let me pause for just a second. That was the core of what I wanted to go through, but happy to answer any questions that folks have before we wrap up.
Great, thanks, Mike. We have one question so far about vulnerability checks. So let me pull this up.
Well,
It says, just want to know how to onboard this into prod environment with vul checks.
yeah, so part of, depending on your requirements, let's pull up that pieces again. There are two places that you can do that, right? One is on the release side, but typically that's going to be run on the collector side as well. So anything that, if you look at the actions, this is where you can see specifically what's happening and where it's happening. And you can dig into all of these. Actually, let me go back and I can show a visual of it. Right, so this is going to be validating Go releaser in this stage. So at the release stage, it's not going to be running vulnerability scans on this. However, if you go into the collector contrib repos, and let me see if I can pull this up and find where those are going to be run. When you're doing any work with, like, this would specifically be a situation if you were developing custom components, then you would really want to consider this as part of the workflow. So it's a good question. It's something where you need to make sure if you are developing things like you're developing your own receivers or processors, that there is a validation step. Now that, depending on how you wanted to structure it, could happen in the repo with the custom component. Then you would follow a standard process where you would build it, validate it, run vulnerability checks against it. Or it could happen in the release process itself if you didn't want to have two. But in the case of OpenTelemetry, that type of vulnerability scanning is typically going to happen in the, say, collector contrib or in the collector repository. And then the validation of once it's built into additional binaries or packages, there'll be some that happens there, but can all be done through actions just like this. So as part of this workflow. Hopefully that answers your question. And I didn't find the specific callouts, but happy to send that out after.
Yep, looks like you answered their question. Thanks.
Great. Yeah, any other questions before we wrap up today?
Nothing in chat, Mike, so I think we're looking pretty good.
Great. Well, feel free to reach out after if there's anything that comes up. It's a really interesting topic for us, one that we deal with a lot. We're going to be talking about observability pipelines, building an observability pipeline with OpenTelemetry, something that we deal with a lot, something that BindPlane focuses on specifically. And we'd love to hear if you have any feedback or thoughts on areas that you'd like to learn more about OpenTelemetry. But that's it for today. Thanks so much for joining, and hopefully see you next time.
Thanks all. Have a good one.